All right, it's time for some division of segments and angles here in section 1.5 of the great honors geometry. Let's hop to it, shall we? First one, we got midpoint. Just like it sounds, a midpoint is going to be smack dab in the middle of that segment, okay? So if a point is a midpoint, then it divides the segment into two congruent segments. It's smack dab in the middle, two congruent segments. Let me see here. Let me get a marker ready. We'll go green. So if I've got something like segment AB, perhaps I have point M, and I have congruent markings. M is a midpoint. It splits it into two congruent segments. Since this is a definition, we can reverse it. If a point is the midpoint of a segment, then it divides the segment into two congruent segments. If a point divides a segment into two congruent segments, then it is a midpoint. Okay, so definitions you can reverse, you can do the converse, and they hold true. If you need to, guys, pause the video to write these definitions down. They are incredibly important, but I'm going to keep it moving so that I can keep the video a little bit smaller, a little shorter video length, short like Mr. Allen. Okay. Yes. All righty. So C is between A and B. Remember, between doesn't mean smack dab in the middle necessarily. If AC is 2x plus 5 and BC is 4x minus 1 and AB is 7x minus 1, is C a midpoint? Perhaps we draw a diagram. So I've got A and B, and C is somewhere in there. I'm not going to draw it smack dab in the middle. It might be. We don't know. We're trying to find that out. It says AC is 2x plus 5. BC is 4x minus 1. And the whole thing is going to be 7x minus 1. So we know with betweenness, if you remember back to the definition of betweenness, and we have betweenness here, it says that C is between, that AC, this segment here, and BC, this segment here, would add up to the whole thing, AB. Let's set up an equation for that. So I would have 2x plus 5 plus 4x minus 1 is equal to 7x minus 1. Now, you could have set this up slightly different. You could set, AC and BC equal to each other and solve for x and see if it works out. But you're assuming stuff that you probably shouldn't really assume, and it leads to some mistakes. So I would go with what we know for sure, and that is that C is between A and B. So AC and BC have to add up to AB. All righty, so I've got 6x plus 4 equals 7x minus 1. I can solve for x. I'll get 5 is equal to x. I subtracted the 6x. I added the 1. Awesome. Well, what do we do with this? That's a good question, right? How about I plug it back in? I'm going to use a different color now. So if I plug in 5 for x, I'm going to have 2 times 5 plus 5. That's going to be 15, right? 10 plus 5 is 15. Here I'm going to have 4 times 5 minus 1. That's going to be 20 minus 1 is 19. C is not the midpoint, okay? You would find that this is going to be 34 here, and it all checks out. Sometimes it's a good idea to plug things back in to see if it checks out. 15 plus 19 is 34. Yeah, that makes sense, right? Cool. Awesome. So in this case, no, not the midpoint. All righty. Angle bisector and trisector definition. So if a ray is an angle bisector or trisector, then it divides the angle into 2 or 3 congruent angles, depending on which one we're talking about. The dividing ray is called the bisector or trisector of the angle. So what we'll say for ours, when we're doing this in proofs, we'll use either definition bisect or definition trisect. And the same will end up applying to segments. We could even add in segments into this definition. It's basically the same thing as you'll see in a sec. Pause it if you need to. A segment bisector or trisector is a segment line or plane that's going to divide a segment into 2 or 3 congruent segments. It's called the bisector or the trisector. And once again, we can say definition bisector or definition trisector. We're fine with that in our proofs. They get very lengthy. Okay, so writing out full definitions, we're not going to do that. All right, but we do want to make sure we make a mental note of what they mean. Okay. Pause it if you need to. Okay, another example. Which ray is the angle bisector? Well, as you notice here with the arcs, this arc and this arc, that means that these two angles are congruent. They have the same marking. Okay, so what can we conclude, or sorry, which one's the bisector? Well, that would be PN. And remember, it's a ray that is doing the angle bisecting, because an angle is made of two rays with a common endpoint, if we remember back to that definition. A lot of definitions to put in the old cabeza. Given the angle bisector, what can I conclude? Well, we can conclude angle MPN is congruent to angle NPR. And that'd be the by definition bisect, or by definition angle bisector, something like that. This is a situation where if you wanted to, you could have numbered these as 1 and 2 and written that in your proof to save a little bit of time, because they are two angles. There's not multiple angles within them. They're the small guys, right? They're the acute ones here in this case. All righty, let's continue. So all we're going to do in this one here is we're going to name, or we're going to say what we can conclude based off of this given information. So we'll just do these together. Normally in class we would do these as a, in your small groups. So it says that O is the midpoint of CD. What can we conclude? Well, I can conclude that CO and DO are congruent. CO is congruent to DO. Can I conclude anything about like AO and BO? Doesn't say that O is the midpoint of AB, okay? And this would just be by definition midpoint, okay? It says SW bisects XV. Okay, well, what can we conclude? Well, if SW is bisecting XV, that would split it into two congruent segments, so it would be that XW is congruent to WV, and our reason would be definition bisect. Cool. Name the congruent angles. Well, if RO bisects NRP, what does that mean? Well, if it bisects this angle, that means it splits it into two congruent angles. So I'm going to have this one is congruent to this one. Even though they don't look it, it says that they are, so we got to go with it. Sometimes these diagrams aren't the best. We would know those two angles are congruent. So angle NRO is congruent to angle PRO. And definition bisect would be our reason. I'm not going to write the definition going forward here. Save a little bit of time. All right. Cool. Two congruent angles. That's exciting stuff. Now we got trisecting happening. All right. So I have XT and XV are trisecting angle SXW. Well, that's taking this big angle and splitting it into three congruent angles. So that would be this one, and this one. We have three congruent angles. So you know what? Yeah, why not? I'll name this one 1, 2, and 3. So I know that angle 1 is congruent to angle 2, and it's congruent to angle 3. How convenient. So in this case, we can label them angles 1, 2, and 3 because we're talking about the smallest angles there, right? Saves us a little bit of writing, a little bit of time. Time is money. That ain't funny. Woo! Alrighty. Continuing. Name the angle bisector. A little bit of a twist. Well, it says that angle FJG and HJG are congruent. Well, what's doing the bisecting? JG, the ray, is doing the bisecting. Even though it doesn't look like a ray in the diagram, because we're talking about angles and because angles are made of two rays with a common endpoint, we do need to refer to JG as a ray. Okay? Wonderful. Cool. Continuing. The measure of angle POK and the measure of angle MOK are equal to each other. Well, that would mean that these two angles are congruent. Cool. Awesome. So if those two angles are congruent, which one's the angle bisector? Well, it'd be OK, and it has to be that direction. All right? Because it's going... This is the vertex of the two angles we're talking about, so that ray is going in that direction, and you can't flip those two letters. You cannot do that with rays. All right? There we go. That was a lot of fun. Name the congruent segments, the congruent angles, and the angle bisectors. I love it. Next example. Woo. We are cruising, ladies and gentlemen. Cruising. Let's do it. So given ST bisects angle RSV, prove that RST is congruent to TSV. So my first one's my given, which is ST bisects angle RSV. My reason's the given. And then step 2 here. So if it bisects it, wouldn't that just tell me that these two are congruent to each other? Awesome. So I'm ready to rock and roll. RST is congruent to angle TSV. A lot of our proofs are pretty quick right now. We're limited on how many theorems and properties on stuff we have. Don't you worry. They will get lengthier. More length. All right. And my reason for that one is definition bisect. Wonderful. Kick the desk there. One thing you cannot do here is we can't name these by two numbers when it's our proof statement. Don't do that because the proof statement is already written out. So if it's not written with numbers, don't change them to numbers. Even though you could name them with numbers within a proof, don't do it for your last step. Okay, that's just bad form. Bad form. Have some class, you know. All righty, example number 4. It says AB is equal to 6 and BC is equal to 6. Prove that B is the midpoint. Well, by definition, midpoint, the midpoint splitting into two congruent segments. So in order to prove this, I need to prove AB is congruent to BC, and I can do so because they're equal measure. So it sounds like we already have ourselves a game plan. So first thing I'm going to do here after the given is AB is congruent to BC. That's by the definition of congruent. And now by the definition of midpoint, I can say I have a midpoint, right? Because the midpoint said it splits into two congruent segments. So B is the midpoint. Definition, midpoint. Voila. Not too bad there. It helps to think through the process here. I can't just say right off the bat that it's a midpoint because the definition of midpoint doesn't say anything about the actual length. It references being congruent. So I have to bring congruent into my proof, okay? It's all about the logical processing throughout this. All righty. Number 5 here. It says C and D, points C and D, trisect BE. So we want to find the values of X and Y. Well, sometimes when we have two variables, we end up having to use a system, but perhaps we don't have to here. Since I know that all 3 of these are congruent, why don't I just take the ones with X's and set them equal to each other? Trisect means that it splits it into 3 congruent segments. So these two we know are congruent to each other, which means they are equal in length. If I solve this, I add 6 over here, subtract 3x, I get x. I get x equals 7. If I plug that back in, got 21, 22, which would mean that this should be 22, but why don't we just double check it? I'm going to have 4 times 7 is 28 minus 6 is indeed 22. So if this one's also 22, what can I do? How about 5y plus 2 is equal to 22? So I'm going to get 5y equals 20. So y is equal to 4 when I solve it. Excellent. Wonderful. Fantastic. Good stuff. Man, this is a lot of fun. I think, I think we'll call it a day here once again, try to keep them a little more focused here. I hope you guys had a great time. Still working on these different types of software here. So, yeah, awesome stuff. America, freedom, rock and roll, and Costco.